everyone, welcome to ExamRat. My name is Shatabdi, I'm a second year medical student. So today we're going to be discussing about some questions from the chapter Light. Okay, so our first question here is that a concave mirror produces 3 times magnified real image of an object placed at 10 centimeter in front of it. Where is the image located? So we know that the magnification formula for a mirror is m equals to minus v by u, which also happens to be equals to height or size of the image by size of the object, right? So now what we have to find is where is the image located, that is we have to find v. U is given to us. So minus v by 10 is equals to, now it's saying that the mirror produced 3 times magnified real image of an object. So obviously the height of the image will be thrice the height of the object, right? Okay. So now from here what we are getting is minus v equals to 30, or we can write v equals to minus 30 centimeter, right? Okay. Also don't forget that when we are talking about mirror, you have to put the negative sign here, right? Okay. So the image is basically located, either you can write v equals to minus 3 centimeter, or you can write image located 30 centimeter in front of mirror, right? Or to the left. Okay. The refractive index of diamond is 2.42. What is the meaning of this? Now this is a very simple question that comes often in give reason. So we knew that refractive index, it had a formula of or rather absolute refractive index we calculated by c divided by v, where c was speed of light in air and v was speed of light in medium, right? So basically, how do we know that absolute refractive index? Absolute refractive index means the actual refractive index, right? Because we are comparing it with the speed of light in air, and this is a constant, right? So basically this is a ratio of the speeds. So what we can say is that when we talk about the refractive index of diamond is 2.42, so for example 2.42 equals to c by v, or v equals to c by 2.42. So you can understand by this formula is that the speed of the light in this medium, in this case which is diamond, so the speed of light in diamond gets reduced by 2.42, by a fraction of 2.42, or gets divided or reduced by a factor of 2.42, which was the actual speed of light. So speed of light gets reduced by a factor of 2.42. Just give a star mark here, in diamond. Okay. The next question asks us, which of the following lenses would you prefer to use while reading small letters found in a dictionary? Okay. So when we are saying small letters in a dictionary, it means it is placed very close to our eyes, right? Okay. So like the letters are very, very small. So what we need is basically something that converges the light rays to our eyes, because our eyes also very small, right? So we basically need a converging lens. And what is that? That is a convex lens. Okay, so from here we can cancel out these two options. Okay, now we know that when we talked about power, we know that power is the reciprocal of focal length. So lesser the focal length, more will be the power. So better will be the convex lens at converging. So here we take the focal length with the lowest number, which is 5 centimeter. So, sorry, this is the concave one. So focal length of 5 centimeter. So basically, this is our option. Convex lens of focal length 5 centimeter. So we have to basically first find the converging lens, and then we have to look for the smallest focal length, because lesser the focal length, more is the power of the lens. Okay. Now, an object of size 7 centimeter is placed at 27 centimeter in front of a concave mirror. Let's just draw it. Of focal length 18 centimeter. This is O, this is F, this is C. So focal length is 18 centimeter. Okay, 18 centimeter. Here we can write minus 18. The object is placed 27 centimeter in front of the concave mirror, so we can somewhere just put it here, right? Because 18 into 18 plus 18, this would have been 36 centimeter, we know, because radius of curvature is twice that of focal length. So anyway, so here is somewhere we can again denote it. (27 centimeter). This will also be negative. At what distance from the mirror should a screen be placed so that the sharply focused image can be obtained? So here they are basically asking you the V or the image distance. How will we find that? We will find that by using our mirror formula, 1 by V plus 1 by U equals to 1 by F. Now we are replacing the values. We don't know V. So 1 by F minus 1 by U. Focal length is 1 by minus 18. Minus U is 27 centimeter, minus rather. So minus 27. 1 by minus 1 by 18 plus 1 by 27, because minus and minus gives us plus. So now we take 54. So minus 3 plus 2, or minus 1 by 54. Therefore, 1 by V equals to minus 1 by 54, or V equals to 54 centimeter minus. Right? So what does this minus indicate? That the image is going to be formed somewhere here. It is going to be real, obviously, because real images can be focused on a screen. So we got the V. Now we can find the size and the nature of the image, right? So what is the size? We know that minus V by U equals to H, or height of image by height of object, right? So here we know minus, what is V? We have minus 54. U we have minus 27. Height of the object we have as 7. We have to find the height of image. So here what we are getting? We are getting height of image as minus 14. So what does this minus mean? It means it is nothing but a real image. It is inverted. So the inversion is given to us by the minus sign, because we know that anything below the principal axis will be negative. So minus 14 centimeter. So 14 centimeter is the height, and nature is inverted. Okay. So 14 centimeter nature will be inverted. Okay. Find the focal length of a lens of power minus 2d. What type of lens is this? So we know again power equals to 1 by focal length, or minus 2 equals to 1 by f, or f equals to 1 by minus half or minus 0.5 centimeter. What type of lens it is? You know that when the focal length is negative, so if this is a convex lens and this is a concave lens, so the concave lens's focus, first focus is here, so it always has a negative focal length, right? So this lens is concave lens. Okay. A doctor has prescribed a corrective lens of power 1 plus 1.5d. Find the focal length of the lens, and is the prescribed lens diverging or converging? Okay, so when we talk about the defects of vision, it will be more clear as to what is a corrective lens. It basically corrects the refractive defect. Okay, so again we find the focal length. So 1.5 equals to 1 by f, or 15 by 10 equals to 1 by f, or f equals to 10 by 15, which is 2/3, which is 0.66 centimeter. Okay, so here it is plus 1.5d. So we know that when focal length is positive, it is a convex lens. So the corrective lens here is convex lens, right? Okay. So these were some very basic questions, and this is all that is going to come within this parameter. Now there can be some value changes, or you can be asked to draw a ray diagram along with finding the image distance or object distance. So that will be all that we asked of you. So thank you for watching. We'll meet at our next class.